Welcome to the Machinist Red Seal exam practice. This video contains 135 practice questions to help you prepare for your certification exam. Let's begin. This exam covers the following major work activities: common occupational skills, bench work, power saws, drill presses, conventional lathes, conventional milling machines, precision grinding machines, and CNC machines. Before we start, if you're preparing for your Red Seal exam, hit subscribe. We cover over 50 trades. Question 1. Which workplace hazard requires machinists to verify the energy state of a machine before performing maintenance? A. Inadequate lighting near the machine tool. B. Lockout-tagout procedures for stored energy isolation. C. Improper stacking of raw material in storage areas. D. Contaminated coolant in the machine sump. The correct answer is B. Lockout-tagout procedures are specifically required to verify and isolate all energy states, electrical, mechanical, hydraulic, and pneumatic, before any maintenance work begins. This prevents unexpected machine activation that could cause serious injury or death. Question 2. A machinist notices hot, irregularly shaped chips being ejected from a lathe during a turning operation. What is the correct first action? A. Stop the machine, adjust the chip breaker geometry or cutting parameters. B. Continue machining and clean chips after the operation is complete. C. Increase the spindle speed to break the chips into smaller pieces. D. Remove the chip guard to improve visibility of the cutting zone. The correct answer is A. Hot, irregularly shaped chips indicate improper cutting parameters or chip breaker geometry. The correct action is to stop the machine and adjust these parameters to produce controlled chip formation. Continuing to machine risks injury from flying chips and potential workpiece damage. Question 3. When interpreting an engineering drawing, which symbol system communicates allowable variations in form, profile, orientation, location, and runout? A. Surface finish symbols using the RA roughness scale. B. Welding symbols per the Canadian Welding Bureau standard. C. Geometric dimensioning and tolerancing symbols. D. Material specification codes from the SAE numbering system. The correct answer is C. Geometric dimensioning and tolerancing, GD&T, is the symbol system that communicates allowable variations in form, profile, orientation, location, and runout on engineering drawings. It provides precise control over part geometry beyond basic dimensional tolerances. Question 4. A machinist receives a work order with conflicting dimensions between the isometric view and the orthographic projection. What is the correct procedure? A. Use the dimensions from the isometric view as they show the complete part. B. Average the two conflicting dimensions and machine to the mean value. C. Use the dimensions from whichever view has the tighter tolerance. D. Flag the discrepancy and consult the designer or supervisor before proceeding. The correct answer is D. When conflicting information exists on a drawing, the machinist must flag the discrepancy and consult the designer or supervisor before machining. Proceeding with incorrect dimensions could result in scrapped parts, wasted material, and production delays. Question 5. When planning a sequence of operations for a shaft requiring rough turning, finish turning, threading, and grinding, which factor primarily determines the operation order? A. The need to maintain dimensional accuracy by progressing from roughing to finishing operations. B. The availability of each machine in the shop schedule. C. The personal preference of the machinist for certain operations. D. The color coding on the raw material stock identification tag. The correct answer is A. The sequence of operations is determined by the need to maintain dimensional accuracy, progressing from roughing to finishing. Rough operations remove bulk material, followed by finish operations that achieve final dimensions and surface finish. Grinding is typically last to achieve the tightest tolerances. Question 6. Which component of active listening involves restating the speaker's message in your own words to confirm understanding? A. Paraphrasing the key points of the communication. B. Reflecting the speaker's emotional state back to them. C. Responding with a detailed technical explanation. D. Hearing the words spoken without interruption. The correct answer is A. Paraphrasing is the active listening component where the listener restates the speaker's message in their own words to confirm understanding. Active listening includes hearing, understanding, reflecting, responding, and paraphrasing as distinct but related components. Question 7. When mentoring an apprentice on a new machining skill, what is the correct sequence after demonstrating the operation? A. Have the apprentice work independently and check the finished part only. B. Assign the apprentice to read the machinery's handbook section before any practice. C. Set up guided practice conditions, then progress to limited and full independence. D. Repeat the demonstration 3 times before allowing any hands-on practice. The correct answer is C. After demonstrating a skill, the mentor should set up guided practice conditions first, then progress to limited independence, and finally full independence. This graduated approach allows the apprentice to build confidence and competence while maintaining safety. Question 8. Which method is used to quickly identify an unknown ferrous metal by observing the color, shape, and quantity of sparks produced? A. Rockwell hardness testing on the B or C scale. B. Magnetic testing with a permanent magnet. C. Spark testing using a bench or pedestal grinder. D. Checking the material test report certificate number. The correct answer is C. Spark testing uses a bench or pedestal grinder to produce sparks from the metal. The color, shape, length, and quantity of sparks indicate the carbon content and alloy composition, allowing quick identification of unknown ferrous metals in the shop. Question 9. Before lifting a large workpiece with an overhead crane, what must the machinist determine first? A. The surface finish requirements of the finished part. B. The approximate weight of the load and its center of gravity. C. The cutting speed and feed rate for the first operation. D. The type of cutting fluid required for the machining process. The correct answer is B. Before any lifting operation, the machinist must determine the approximate weight of the load and its center of gravity. This information is essential for selecting appropriate rigging equipment, ensuring the crane capacity is not exceeded, and planning a safe lift path. Question 10. A machinist needs to increase the wear resistance of a low-carbon steel shaft while maintaining a tough core. Which heat treatment sequence achieves this? A. Case hardening by carbizing the surface, then quenching and tempering. B. Full annealing followed by normalizing to relieve internal stresses. C. Through hardening by oil quenching followed by deep cryogenic treatment. D. Stress relieving at subcritical temperature for an extended soak period. The correct answer is A. Case hardening by carbizing introduces carbon into the surface of low-carbon steel, creating a hard, wear-resistant outer layer. The subsequent quench hardens the carbized surface while the low-carbon core remains tough and ductile, providing the ideal combination of surface hardness and core toughness. Question 11. When lubricating machine tool slideways, what documentation must the machinist consult to select the correct lubricant type and application interval? A. The machinery's handbook section on cutting fluid selection. B. The machine manufacturer's maintenance documentation and schedule. C. The Provincial Occupational Health and Safety Regulation Manual for Machine Maintenance. D. The WHMIS Safety Data Sheet for the workshop cutting oils. The correct answer is B. The machine manufacturer's maintenance documentation specifies the correct lubricant type, application locations, required levels, and maintenance intervals for each machine. Using incorrect lubricants can cause premature wear, loss of accuracy, and voiding of warranty coverage. Question 12. What environmental condition is required when performing basic calibration of precision measuring instruments such as gauge blocks? A. A temperature-controlled environment to prevent thermal expansion errors. B. A well-ventilated area with strong directional lighting. C. An area isolated from electrical equipment to prevent magnetic interference. D. A humidity-free clean room with positive air pressure filtration. The correct answer is A. Precision measuring instruments must be calibrated in a temperature-controlled environment, typically maintained at 20 degrees Celsius, 68 degrees Fahrenheit. Temperature variations cause thermal expansion or contraction of both the instruments and reference standards, introducing measurement errors that compromise calibration accuracy. Question 13. What is the purpose of applying Prussian blue to a workpiece surface before performing layout operations? A. To indicate areas that require additional heat treatment. B. To protect the surface from corrosion during storage. C. To provide a visible contrast coating so scribed lines are clearly seen. D. To lubricate the surface for smoother file contact during finishing. The correct answer is C. Prussian blue is applied as a layout dye to create a contrasting background on the workpiece surface. When scribed lines are drawn through the coating, the bright metal underneath becomes clearly visible against the blue background, ensuring accurate layout transfer from drawings to workpiece. Question 14. Which measuring instrument is used with a surface plate and height gauge to verify the flatness of a machined surface during layout? A. An outside micrometer with a ratchet stop. B. A thread pitch gauge held against the workpiece. C. A telescoping gauge inserted into a bored hole. D. A dial indicator mounted on a height gauge stand. The correct answer is D. A dial indicator mounted on a height gauge stand is used with a surface plate to verify flatness. The surface plate provides a precision reference plane, and the dial indicator measures deviations as it traverses the workpiece surface, revealing any high or low spots. Question 15. A machinist is filing a flat surface and notices the file is leaving deep scratches and sliding unevenly. What is the most likely cause? A. The file teeth are pinned with embedded metal particles from previous use. B. The workpiece material is too soft for any filing operation. C. The file is a single-cut type which is too aggressive for the material. D. The file handle is installed at an incorrect angle to the tang. The correct answer is A. File pinning occurs when metal particles become embedded between the file teeth, creating raised points that scratch the workpiece surface and cause uneven cutting. Using a file card to clean the teeth regularly prevents pinning and maintains consistent file performance. Question 16. When laying out hole positions on a workpiece, what is the correct sequence before drilling? A. Center drill first, then scribe reference lines, then prick punch. B. Prick punch at the intersection of scribed lines, then center punch to enlarge the mark. C. Drill a pilot hole, then use a transfer punch to mark the final position. D. Scribe circles at the hole diameter, then drill directly without punching. The correct answer is B. The correct sequence is to scribe reference lines first, then use a prick punch at their intersection to create a small precise mark, followed by a center punch to enlarge the indentation. The center punch mark guides the center drill and prevents the drill from wandering. Question 17. What determines the selection of a tap for cutting internal threads in a blind hole? A. The color coding stamped on the tap shank by the manufacturer. B. The thread class, pitch, and hole depth relative to the tap chamfer length. C. The hardness of the tap measured on the Rockwell C scale only. D. The overall length of the tap handle and wrench clearance above the hole. The correct answer is B. Tap selection for blind holes depends on the thread class, fit tolerance, pitch, threads per unit length, and the relationship between hole depth and tap chamfer length. A bottoming tap with a short chamfer is needed when threads must extend close to the bottom of a blind hole. Question 18. When installing a helicoil thread insert into a strip tapped hole, what must be done before inserting the coil? A. The hole must be reamed smooth to remove all existing thread profiles. B. The original threads must be filled with epoxy and allowed to cure fully. C. A new hole must be drilled adjacent to the original and offset by 1 thread pitch. D. The hole must be re-drilled and tapped to the helical specified oversized tap drill. The correct answer is D. Before installing a helicoil insert, the damaged hole must be drilled out to the specified oversized drill diameter and then tapped with the special helicoil tap. This creates the correct internal thread profile to accept the helical wire insert, which restores the original thread size. Question 19. When broaching a keyway in a bore using a hand broach, how is the broach guided to maintain alignment with the bore axis? A. The broach is freehand guided while applying steady downward pressure. B. A bushing or guide fixture is inserted into the bore to align the broach. C. The workpiece is rotated against the stationary broach at low speed. D. A magnetic base clamp holds the broach in position during the cutting stroke. The correct answer is B. A bushing or guide fixture is inserted into the bore to support and align the broach during the cutting stroke. This ensures the keyway is cut parallel to the bore axis and at the correct angular position, producing a properly aligned key seat. Question 20. When using an arbor press to install a bushing into a housing bore, what work-holding method protects both the bushing and the operator? A. Holding the housing by hand on the press bed while pressing slowly. B. Clamping the bushing with locking pliers and pushing it in by hand. C. Securing the housing in a vise with soft jaws and aligning the bushing with the ram. D. Placing the housing loosely on parallels with no clamping required. The correct answer is C. Securing the housing in a vise with soft jaws prevents the workpiece from moving during pressing and protects the finished surfaces. The bushing must be aligned with the press ram to ensure it enters the bore squarely, preventing binding, damage, or ejection of the workpiece. Question 21. When disassembling a multi-component assembly for refurbishment, what documentation practice ensures correct reassembly? A. Listing only the total number of fasteners removed from the assembly. B. Measuring only the largest component dimension before disassembly. C. Placing all removed components into a single container for batch cleaning. D. Recording the disassembly sequence with photographs, sketches, and component marking. The correct answer is D. Recording the disassembly sequence with photographs, sketches, and component marking ensures that all parts can be correctly identified and returned to their original positions during reassembly. This is critical for maintaining proper fits, alignments, and functional relationships between components. Question 22. During component analysis for refurbishment, which inspection method determines whether a worn shaft can be salvaged or must be replaced? A. Visual inspection for surface color changes only. B. Comparing measured dimensions against original drawing tolerances. C. Weighing the shaft and comparing it to the catalog listing. D. Checking the part number against the manufacturer's current inventory. The correct answer is B. Comparing measured dimensions against the original drawing tolerances determines whether a worn component falls within acceptable limits for continued service. If dimensions are outside tolerance, the shaft may require machining to an undersize with a sleeve, chrome plating, or replacement. Question 23. A refurbished gearbox assembly exhibits excessive backlash after reassembly despite all individual gear dimensions being within tolerance. What is the most likely cause? A. The lubricant grade selected is too heavy for the operating temperature. B. The gears were reassembled with incorrect center distances between shafts. C. The gear teeth were magnetized during the cleaning process. D. The gearbox housing was painted before reassembly, adding material thickness. The correct answer is B. Excessive backlash with intolerance gears indicates incorrect center distances between the shafts. Even small changes in shaft spacing significantly affect gear mesh clearance. This can result from worn bearing bores in the housing, incorrect shim thickness, or misalignment during reassembly. Question 24. Which type of power saw is best suited for cutting irregular shapes and contours from sheet or plate material? A. Horizontal band saw with a gravity feed mechanism. B. Reciprocating power hacksaw with an adjustable stroke length. C. Vertical band saw with a contour-cutting blade guide. D. Abrasive cutoff saw with a reinforced grinding disc. The correct answer is C. A vertical band saw is specifically designed for cutting irregular shapes and contours. The vertical blade orientation allows the operator to guide the workpiece on a flat table, following layout lines for curved and intricate cuts that other saw types cannot perform. Question 25. When selecting a band saw blade for cutting thin-walled tubing, what tooth pitch requirement must be met? A. The blade must have the finest pitch available to produce a mirror finish. B. A skip tooth pattern must be used regardless of wall thickness. C. The tooth pitch must match the outside diameter of the tubing exactly. D. At least 2 to 3 teeth must be in contact with the workpiece wall thickness at all times. The correct answer is D. When cutting thin-walled materials, at least 2 to 3 teeth must engage the workpiece wall thickness simultaneously. If too few teeth are in contact, individual teeth can catch and strip, causing blade damage and a rough cut. This is determined by the material cross-sectional thickness. Question 26. When installing a new blade on a horizontal band saw, what must be verified before starting the machine? A. The coolant reservoir is completely drained for a dry test cut. B. The blade tension is set to minimum to prevent premature blade fatigue. C. The blade teeth are pointing in the direction of blade travel toward the cut. D. The work stop is removed to allow unrestricted material movement. The correct answer is C. The blade teeth must point in the direction of blade travel, cutting into the workpiece on the downstroke for horizontal band saws. Installing the blade with teeth pointing in the wrong direction results in no cutting action, excessive heat, and rapid blade dulling. Question 27. What is the primary purpose of a work stop on a horizontal band saw when cutting multiple pieces to the same length? A. To clamp the workpiece firmly during the cutting operation. B. To support the cut-off piece and prevent it from falling to the floor. C. To prevent the saw blade from overtraveling past the material. D. To position the material at a repeatable distance from the blade for consistent cut lengths. The correct answer is D. A work stop positions the material at a repeatable distance from the blade, ensuring all pieces are cut to the same length without individual measurement. This increases efficiency and consistency when producing multiple identical parts in a production run. Question 28. Which type of power saw uses an abrasive disc rather than a toothed blade to cut hardened steel and other difficult-to-cut materials? A. A friction saw operating at extremely high surface speeds. B. A cold circular saw with carbide-tipped teeth. C. A contour band saw with a diamond-coated blade. D. An abrasive cutoff saw with a reinforced grinding wheel. The correct answer is D. An abrasive cutoff saw uses a reinforced grinding disc that cuts through hardened steel and other hard materials by abrasive action rather than tooth cutting. The disc removes material as fine particles, making it effective for materials that would quickly dull conventional toothed blades. Question 29. When making an angled cut on a horizontal band saw, what must be adjusted and verified before starting the cut? A. The blade must be replaced with a wider blade to maintain rigidity at an angle. B. The blade speed must be doubled to compensate for the longer cut path. C. The saw head or vise must be adjusted to the required angle and verified with a protractor. D. The coolant flow must be turned off to prevent it from deflecting off the angled surface. The correct answer is C. For angled cuts, the saw head or vise must be adjusted to the required angle and verified with a protractor or angle gauge. The end of the material should first be squared off as a reference cut, then the angle set accurately to produce the specified bevel or miter. Question 30. During a straight cut on a horizontal band saw, the blade begins to wander off the scribed line. What is the most likely root cause? A. The coolant concentration is too high, lubricating the blade excessively. B. The blade guides are worn or incorrectly positioned, allowing lateral blade movement. C. The workpiece material has uniform hardness throughout the cross-section. D. The work stop is positioned too close to the blade for the material width. The correct answer is B. Blade wandering is most commonly caused by worn or incorrectly adjusted blade guides. The guides support the blade laterally during cutting. When they are worn or set too far from the blade can deflect sideways under cutting forces, causing the cut to drift off the intended line. Question 31. When cutting an irregular contour on a vertical band saw, what technique prevents blade binding in tight radius curves? A. Increasing the blade speed to the maximum setting for faster material removal. B. Making relief cuts from the edge of the material to the contour line before cutting the shape. C. Using the widest available blade to maximize rigidity through the curve. D. Applying heavy downward pressure to force the blade through the curve quickly. The correct answer is B. Relief cuts are short straight cuts made from the edge of the material to the contour line at intervals around tight curves. As the contour is cut, waste material falls away at each relief cut, preventing the blade from binding in tight radii where a continuous cut would twist the blade. Question 32. Which type of drill press allows the spindle to be moved horizontally along an arm to drill holes at various locations on a large workpiece without repositioning the part? A. A radial arm drill press with a traversing spindle head. B. A sensitive drill press with a hand feed lever. C. An upright drill press with a fixed column and adjustable table. D. A magnetic base drill with a portable electromagnet mount. The correct answer is A. A radial arm drill press has a spindle head that traverses horizontally along a rigid arm, which can also swing around the column. This allows the operator to position the drill at various locations on a large workpiece without the need to reposition heavy parts. Question 33. What information is required to calculate the correct spindle speed, RPM, for a drill press operation? A. The depth of the hole and the hardness of the drill bit only. B. The length of the drill flutes and the type of drill press being used. C. The recommended surface speed for the material and the diameter of the cutting tool. D. The weight of the workpiece and the distance from the column to the spindle. The correct answer is C. Spindle speed, RPM, is calculated using the recommended surface speed for the workpiece material and the diameter of the cutting tool. The formula RPM equals surface speed times 1000 over pi times diameter converts the material-specific cutting speed to the required rotational speed for the specific tool diameter. Question 34. When clamping a workpiece in a drill press vise for a drilling operation, what prevents the workpiece from spinning if the drill catches? A. The vise must be bolted or clamped to the drill press table to resist torque. B. The weight of the workpiece alone is sufficient to resist rotation. C. The drill press speed should be set to maximum to avoid catching. D. A center punch mark eliminates all risk of the drill catching the material. The correct answer is A. The vise must be securely bolted or clamped to the drill press table. If a drill catches or grabs the workpiece, the resulting torque can spin an unsecured vise violently, causing serious injury. This is especially critical during breakthrough when the drill exits the bottom of the hole. Question 35. Before drilling a hole with a large diameter twist drill, why is a center drill used first? A. The center drill preheats the material to reduce drill wear. B. The center drill creates a pilot hole and countersink that guides the larger drill and prevents it from wandering. C. The center drill deburs the top surface before the main drilling operation. D. The center drill measures the material thickness to set the correct depth stop. The correct answer is B. A center drill creates a small pilot hole with a countersink that matches the angle of the larger drill's chisel edge. This guides the larger drill into the correct position and prevents it from wandering across the workpiece surface at the start of the cut. Question 36. When planning drill press operations, which reference material provides recommended cutting speeds for various workpiece materials and drill types? A. The Provincial Occupational Health and Safety Regulation Handbook for Drill Press Safety. B. The Machinery's Handbook and Cutting Tool Manufacturer's Specifications. C. The Drill Press Operator's Personal Experience Log Book. D. The WHMIS Safety Data Sheet for the drill coolant being used. The correct answer is B. The Machinery's Handbook and Cutting Tool Manufacturer's Specifications provide recommended cutting speeds, feeds, and other parameters for various material and tool combinations. These published references give scientifically determined starting values for optimal drill press operation. Question 37. While drilling a deep hole in steel on a drill press, the machinist must periodically retract the drill to clear chips. What is this technique called? A. Peck drilling to break and evacuate chips from the flutes. B. Step drilling to progressively increase the hole diameter. C. Spot facing to create a flat surface around the hole perimeter. D. Counterboring to create a stepped hole for a socket head cap screw. The correct answer is A. Peck drilling involves periodically retracting the drill from the hole to break the chips and allow coolant to reach the cutting edges. This prevents chip packing in the flutes, reduces heat buildup, and avoids drill breakage in deep hole applications. Question 38. What is the correct procedure to produce a counterbore for a socket head cap screw on a drill press? A. Drill an oversized hole and use a flat bottom end mill to clean up the sides. B. Use the counterbore tool first to establish the recess, then drill through the center. C. Drill the clearance hole first, then use a counterbore tool with a pilot that fits the drilled hole. D. Drill the clearance hole and then use a standard twist drill at a larger diameter for the recess. The correct answer is C. The clearance hole is drilled first, then a counterbore tool with a pilot that fits the drilled hole is used to create the flat-bottomed recess. The pilot keeps the counterbore concentric with the existing hole, ensuring the cap screw head sits squarely in the recess. Question 39. When tapping a blind hole on a drill press using a tapping head, what controls the depth to prevent the tap from bottoming out and breaking? A. The drill press depth stop is set to limit spindle travel to the required thread depth. B. The operator listens for a change in motor sound as the tap approaches the bottom. C. The tapping head clutch is set to slip at the predetermined torque limit. D. The spindle speed is gradually reduced as the tap nears the bottom of the hole. The correct answer is A. The drill press depth stop is set to limit the spindle travel to the required thread depth, preventing the tap from advancing too far into a blind hole. This mechanical stop provides a positive limit that is more reliable than operator feel or torque-based methods alone. Question 40. A reamed hole on a drill press measures 0.02 mm undersize and has a rough surface finish. The reamer appears sharp and the speed is correct. What adjustment would most likely solve both issues? A. Increase the spindle speed significantly to generate more heat for expansion. B. Reduce the feed rate and ensure adequate cutting fluid reaches the reamer flutes. C. Replace the reamer with one that is 0.5 mm larger than the desired hole size. D. Remove the reamer and use a boring bar to achieve the final hole size instead. The correct answer is B. An undersize hole with a rough finish from a sharp reamer typically indicates excessive feed rate or insufficient lubrication. Reducing the feed rate allows each flute to remove a more uniform chip, while adequate cutting fluid reduces friction and heat. Together, these corrections improve both size accuracy and surface finish. Question 41. Which type of conventional lathe features a hexagonal tool holder that indexes to preset positions for rapid tool changes during production runs? A. A turret lathe with an indexing tool turret. B. An engine lathe with a quick change tool post. C. A vertical boring mill with a ram-type head. D. A bench lathe with a standard lantern tool post. The correct answer is A. A turret lathe features a hexagonal, or other multi-sided, tool turret that indexes to preset positions, each holding a different cutting tool. This allows rapid sequential tool changes for production turning, drilling, boring, and threading without manual tool setup between operations. Question 42. When planning operations for a shaft requiring facing, rough turning, finish turning, grooving, and threading, which operation should be performed last? A. Threading to the specified pitch and class of fit. B. Rough turning to remove bulk material to near final diameter. C. Facing both ends to establish reference surfaces. D. Finish turning to achieve the final diameter and surface finish. The correct answer is A. Threading should be performed last because the thread profile is fragile and easily damaged by subsequent operations. Additionally, work holding on threaded surfaces is difficult. The correct sequence is facing, rough turning, finish turning, grooving, then threading. Question 43. What is the primary advantage of a 4-jaw independent chuck over a 3-jaw universal chuck? A. The 4-jaw chuck grips round stock more quickly with no setup required. B. The 4-jaw chuck is lighter and easier to mount on the spindle. C. Each jaw adjusts independently, allowing both round and irregular shapes to be centered precisely. D. The 4-jaw chuck can only hold square stock while the 3-jaw holds round stock. The correct answer is C. Each jaw on a 4-jaw independent chuck adjusts separately, which is its primary advantage. This independent movement allows the machinist to precisely center round, square, rectangular, and irregularly shaped workpieces that would be impossible to hold accurately in a self-centering chuck. Although setup takes longer, the versatility and precision of individual jaw control make this chuck indispensable for non-standard work holding. Question 44. When mounting a long slender shaft between centers on a lathe, what accessory prevents the workpiece from deflecting away from the cutting tool? A. A steady rest or follower rest positioned near the cutting zone. B. A faceplate with clamping straps bolted to the surface. C. A collet chuck that grips the entire length of the shaft. D. A lathe dog attached to both ends of the workpiece simultaneously. The correct answer is A. A steady rest or follower rest supports the workpiece near the cutting zone to prevent deflection from cutting forces. A steady rest is fixed to the bed and supports from 3 points, while a follower rest mounts on the carriage and moves with the cutting tool. Question 45. When setting up a right-hand turning tool in a quick change tool post, how should the cutting edge be positioned relative to the lathe center line? A. Slightly below center to prevent the tool from climbing over the workpiece. B. Exactly on center height for optimal cutting geometry and surface finish. C. Well above center to increase the effective rake angle of the tool. D. At any height since the tool post compensates automatically for alignment. The correct answer is B. The cutting edge must be positioned exactly on the lathe center height. If set above center, the tool rubs instead of cutting. If set below center, the tool tends to dig in. On-center positioning ensures the correct effective rake and clearance angles for optimal cutting performance and surface finish. Question 46. What is the purpose of a taper attachment on a conventional lathe? A. To hold tapered shank drills in the tailstock for hole-making operations. B. To offset the tailstock for turning short, steep tapers on shaft ends. C. To generate accurate tapers over a set length while the carriage feeds normally along the bed. D. To measure the included angle of an existing taper on the workpiece. The correct answer is C. A taper attachment is a device mounted on the lathe bed that guides the cross slide at an angle while the carriage feeds along the bed. This generates accurate tapers over a set length without offsetting the tailstock, and the workpiece remains between centers for concentricity. Question 47. Before performing a facing operation on a workpiece held in a 3-jaw chuck, what must the machinist verify to ensure the part runs true? A. That the tailstock center is engaged in the workpiece center hole. B. That the chuck jaw pressure is at the maximum setting for rigidity. C. That the carriage lock is engaged to prevent longitudinal movement. D. That the workpiece runout is within acceptable limits using a dial indicator. The correct answer is D. The machinist must verify that the workpiece runout is within acceptable limits by placing a dial indicator against the rotating workpiece surface. Excessive runout means the part is not centered properly in the chuck, which would produce a face that is not perpendicular to the axis of rotation. Question 48. Which factors determine the correct spindle speed setting for a conventional lathe turning operation? A. The length of the workpiece and the depth of cut required. B. The type of chuck used and the condition of the lathe bed ways. C. The workpiece material, cutting tool material, and the diameter being machined. D. The ambient temperature of the shop and the coolant flow rate. The correct answer is C. Spindle speed is determined by the workpiece material, which sets the surface speed, the cutting tool material, HSS versus carbide versus ceramic, and the diameter being machined. The formula RPM equals CS times 1000 over pi times D converts surface speed and diameter to the required rotational speed. Question 49. What advantage does a carbide insert turning tool have over a high-speed steel, HSS, turning tool? A. Carbide inserts can be resharpened more easily on a bench grinder. B. Carbide inserts maintain hardness at higher cutting temperatures, allowing faster surface speeds. C. Carbide inserts are more flexible and resist breakage from interrupted cuts. D. Carbide inserts are less expensive than HSS tools for all applications. The correct answer is B. Carbide inserts maintain their hardness at much higher temperatures than HSS, allowing significantly faster surface speeds and higher material removal rates. This hot hardness property means carbide can cut at speeds 3 to 5 times faster than HSS for most materials. Question 50. When selecting a work-holding device for turning an eccentric feature on a crankshaft, which setup method allows the axis of rotation to be offset from the geometric center? A. Mounting in a 3-jaw universal chuck centered on the main journal. B. Supporting between centers using the existing center holes. C. Clamping in a collet chuck that automatically centers the workpiece. D. Using a 4-jaw independent chuck with each jaw adjusted to offset the axis of rotation. The correct answer is D. A 4-jaw independent chuck allows each jaw to be adjusted separately, enabling the machinist to deliberately offset the axis of rotation from the geometric center of the workpiece. This is essential for turning eccentric features where the machined surface has a different center than the main axis. If you're finding these questions helpful, please subscribe and hit the bell icon. It helps other apprentices find this resource too. Now let's continue. Question 51. When setting up a steady rest on an engine lathe to support a long shaft, what surface preparation is required at the contact points? A. The contact area must be rough-turned to provide friction for the rest jaws. B. The contact area must be turned smooth and true to provide a concentric bearing surface for the rest jaws. C. The contact area must be knurled to prevent the rest jaws from slipping. D. No surface preparation is needed as the rest jaws self-adjust to any surface condition. The correct answer is B. The contact area where the steady rest jaws bear on the workpiece must be turned smooth and true, concentric with the lathe axis. This ensures the rest jaws support the workpiece without introducing vibration, eccentricity, or scoring that would affect the accuracy of the final machined surfaces. Question 52. A thin-walled tube must be held in a lathe chuck for an internal boring operation. Standard 3-jaw chuck jaws distort the tube. What is the best work-holding solution? A. Increase jaw pressure until the tube grips firmly without visible deformation. B. Hold the tube in the tailstock with a live center pushed into the bore end. C. Pack the bore with shop rags to resist the clamping force from the jaws. D. Use a collet chuck or expanding mandrel that distributes clamping force evenly around the circumference. The correct answer is D. A collet chuck or expanding mandrel distributes clamping force evenly around the full circumference of the tube, preventing localized deformation. Standard 3-jaw chucks apply force at only 3 points, which causes thin-walled parts to deform into a triangular shape, producing an out-of-round bore. Question 53. When setting up a workpiece between centers on a lathe using a lathe dog, what drives the workpiece to rotate with the spindle? A. Friction between the dead center in the tailstock and the center hole. B. A magnetic chuck on the spindle nose attracts the steel workpiece. C. The clamping force of the lathe dog alone is sufficient to transmit torque. D. A drive plate or faceplate on the spindle that engages the tail of the lathe dog. The correct answer is D. A drive plate or faceplate mounted on the spindle has a slot or pin that engages the bent tail of the lathe dog. As the spindle rotates, it drives the lathe dog, which in turn drives the workpiece. The centers only locate and support the workpiece axially. Question 54. When selecting cutting speed for a conventional lathe operation, what happens if the speed is set too high for the workpiece material? A. The surface finish improves but the dimensional accuracy decreases slightly. B. Excessive heat is generated, causing rapid tool wear, poor surface finish, and potential workpiece damage. C. The chip thickness increases, producing long continuous chips that are easy to manage. D. The cutting forces decrease, reducing the power required from the lathe motor. The correct answer is B. Excessive cutting speed generates excessive heat at the tool workpiece interface, which accelerates tool wear, degrades surface finish, and can cause work hardening or thermal damage to the workpiece. Each combination of workpiece and tool material has an optimal speed range for efficient cutting. Question 55. When facing a workpiece on a conventional lathe, in which direction should the cutting tool feed to produce the best surface finish? A. From the outside diameter toward the center of the workpiece. B. From the center of the workpiece toward the outside diameter. C. Alternating between center to outside and outside to center passes. D. Along the axis of the workpiece parallel to the lathe bed. The correct answer is A. For facing, the tool should feed from the outside diameter toward the center. This approach maintains consistent surface speed, which decreases toward center, and produces a better surface finish. It also prevents the tool from being pushed away from the workpiece at the start of the cut. Question 56. During a finish turning pass on an engine lathe, what two parameters most directly control the resulting surface finish? A. The feed rate and the nose radius of the cutting tool insert. B. The spindle speed and the depth of cut selected for the pass. C. The type of chuck used and the tailstock quill extension. D. The coolant temperature and the ambient shop humidity level. The correct answer is A. Surface finish on a lathe is primarily determined by the feed rate and the nose radius of the cutting tool. A smaller feed rate and larger nose radius produce a finer theoretical surface finish. The relationship is expressed as Ra equals F squared over 32 times R, where F is feed and R is nose radius. Question 57. When drilling a center hole in the end of a shaft held in a lathe chuck, what holds the center drill and feeds it into the workpiece? A. The carriage tool post with the center drill clamped in a tool holder. B. The headstock spindle with the center drill replacing the live center. C. A steady rest positioned at the tailstock end of the shaft. D. The tailstock chuck or drill chuck mounted in the tailstock quill. The correct answer is D. The center drill is held in a drill chuck mounted in the tailstock quill. The tailstock is positioned near the rotating workpiece, and the quill is advanced by the handwheel to feed the center drill into the end of the shaft, creating a 60-degree center hole for subsequent operations. Question 58. Which type of measuring instrument is best suited for checking the internal diameter of a bored hole on a lathe? A. An outside micrometer placed across the opening of the hole. B. A depth micrometer inserted from the end face of the workpiece. C. A telescoping gauge expanded in the bore, then measured with an outside micrometer. D. A thread pitch gauge pressed against the bore wall surface. The correct answer is C. A telescoping gauge is expanded inside the bore to contact opposing surfaces, then locked and carefully removed. The gauge is then measured with an outside micrometer to determine the bore diameter. This two-step method provides accurate internal measurements without expensive bore gauges. Question 59. What is the purpose of reaming a hole on a lathe after drilling and boring? A. To enlarge the hole significantly beyond the drilled diameter. B. To create a tapered hole for a Morse taper shank fitting. C. To cut internal threads for a fastener application. D. To produce a precise hole diameter with a superior surface finish. The correct answer is D. Reaming removes a small amount of material from a previously drilled or bored hole to produce a precise diameter with a superior surface finish. A reamer is a multi-flute finishing tool that removes only 0.1 to 0.4 mm of material, producing hole tolerances as tight as H7. Question 60. When turning a Morse taper on a conventional lathe using the compound rest method, how is the correct taper angle set? A. The tailstock is offset laterally by the calculated amount using the set-over screws. B. The cross slide is fed at an angle while the carriage remains stationary. C. The taper attachment is connected and adjusted to the full included angle. D. The compound rest is rotated to half the included angle of the Morse taper. The correct answer is D. When using the compound rest method, the compound is rotated to half the included angle of the desired taper. Since the compound feeds at an angle to the lathe axis, cutting on one side only, it generates the taper at half the included angle per side. Question 61. What is the primary purpose of knurling a cylindrical surface on a lathe? A. To reduce the diameter of the workpiece to final tolerance. B. To improve the surface finish to a mirror-like quality. C. To cut helical grooves for lubrication channels on bearing surfaces. D. To create a textured grip pattern or to provide a surface for press-fit assembly. The correct answer is D. Knurling produces a crosshatched or straight-line pattern on a cylindrical surface by displacing material with a hardened roller. The textured surface provides a grip pattern for manual handling or creates a slightly enlarged diameter for press-fit applications in soft materials. Question 62. When cutting an O-ring groove on a shaft using a conventional lathe, what must be verified after the grooving operation? A. The groove width, diameter, and surface finish meet the O-ring specification requirements. B. The groove is filled with lubricant before the O-ring is installed. C. The groove edges are left sharp to create a positive seal against the O-ring. D. The shaft diameter adjacent to the groove has been reduced by the groove tool width. The correct answer is A. O-ring grooves require precise dimensions, width, diameter, and surface finish, to ensure proper O-ring compression and seal function. The groove must match the O-ring specification for squeeze percentage, and the surface finish must be smooth enough to prevent seal damage and leakage. Question 63. When cutting a unified thread on a conventional lathe, what does the term threads per inch, TPI, define? A. The number of complete thread crests that occur in 1 linear inch measured parallel to the thread axis. B. The total number of complete threads along the entire length of the shaft. C. The depth of each thread measured from the crest to the root. D. The angle between the two flanks of a single thread form. The correct answer is A. Threads per inch, TPI, defines the number of complete thread crests occurring within 1 linear inch measured parallel to the thread axis. It is the reciprocal of the pitch, TPI equals 1/pitch in inches, and determines the gear train setup on the lathe for thread cutting. Question 64. When cutting an external thread on a conventional lathe, why is the compound rest typically set at 29 degrees to the workpiece axis? A. To feed the tool into the work along one flank of the thread, reducing cutting forces and improving chip flow. B. To align the cutting tool with the thread helix angle for accurate pitch. C. To allow the cross slide to retract the tool at the end of each pass without disengaging the half nut. D. To compensate for the spring back of the workpiece material during threading. The correct answer is A. Setting the compound at 29 degrees, slightly less than the 30-degree half angle of a 60-degree thread form, feeds the tool primarily along one flank of the thread. This shears the chip from one side rather than both, reducing cutting forces, improving chip flow, and producing a better thread surface finish. Question 65. During thread cutting on a lathe, the half nut lever must be engaged at the correct position to ensure the tool enters the same groove on each pass. What device indicates the correct engagement point? A. The digital readout display showing the carriage position. B. The micrometer collar on the compound rest hand wheel. C. The spindle speed tachometer reading on the headstock. D. The thread dial indicator mounted on the carriage apron. The correct answer is D. The thread dial indicator, thread chasing dial, is mounted on the carriage apron and shows numbered lines that rotate as the lead screw turns. For specific thread pitches, the half nut must be engaged when the dial reads at specific marked positions to ensure the tool re-enters the same thread groove. Question 66. When parting off a workpiece on a conventional lathe, what tool positioning and speed considerations apply? A. Set the parting tool above center and increase spindle speed for a cleaner cut. B. Angle the parting tool 15 degrees to the workpiece face and use maximum feed rate. C. Position the parting tool exactly on center and reduce spindle speed compared to turning operations. D. Set the parting tool below center and turn off the coolant to prevent thermal shock. The correct answer is C. The parting tool must be positioned exactly on the lathe center height to prevent climbing or digging in. Spindle speed is reduced compared to normal turning because the effective cutting diameter decreases as the tool feeds toward center, which would otherwise cause excessive surface speed. Question 67. A bore in a lathe turn part measures correctly at room temperature, but the mating shaft will not fit during assembly. The shaft also measures within tolerance. What is the most likely explanation? A. The bore and shaft were measured with different brands of micrometers. B. The bore has excessive surface roughness that effectively reduces the usable diameter. C. The bore is out of round due to insufficient clamping rigidity during boring, creating a slightly oval shape. D. The shaft material is a different alloy than specified on the drawing. The correct answer is C. If both bore and shaft measure within tolerance but the shaft will not fit, the bore is likely out of round, oval or lobed. This occurs when the workpiece deforms under clamping forces during boring, for example, thin-walled parts in a 3-jaw chuck. A 2-point measurement, micrometer, may show intolerance in one axis but miss the larger dimension at another angle. Question 68. What is the included angle of a standard Morse taper used in lathe tailstocks and drill press spindles? A. Exactly 60 degrees for all Morse taper sizes. B. Approximately 3 degrees per foot, about 1.5 degrees per side, varying slightly by taper number. C. A uniform 7 degrees included angle across all Morse taper numbers. D. The angle depends on the spindle speed rather than the taper number designation. The correct answer is B. Morse tapers have an approximately 3 degrees per foot, roughly 1.5 degrees per side, taper rate, with slight variations between the different taper numbers, MT0 through MT7. This self-holding taper provides accurate alignment and is retained by friction in the tapered socket. Question 69. Which type of conventional milling machine has both a horizontal spindle and a universal table that can be swiveled for helical milling operations? A. A vertical milling machine with a tilting head. B. A horizontal over universal milling machine with a swivel table. C. A ram and turret milling machine with a repositionable head. D. A jig borer with a precision coordinate table. The correct answer is B. A horizontal over universal milling machine features a horizontal spindle and a table that can swivel in the horizontal plane. This swiveling capability, combined with a dividing head, allows the machine to cut helical features such as helical gears, flutes on drills, and milling cutters. Question 70. What is a jig borer primarily used for in conventional machining? A. Heavy stock removal from large castings and forgings. B. Precision hole location and boring to extremely tight positional tolerances. C. High-speed face milling of large flat surfaces. D. Cutting external threads on long shafts using a single-point tool. The correct answer is B. A jig borer is a precision milling machine designed specifically for accurately locating and boring holes to extremely tight positional and dimensional tolerances. It is used for making jigs, fixtures, dies, and molds where hole location accuracy of plus or minus 0.005 mm or better is required. Question 71. When planning a milling operation that requires machining 6 flat surfaces on a rectangular block, which surfaces should be machined first to establish reference datums? A. The 2 smallest surfaces to minimize initial material removal. B. Any surface can be machined first since the order does not affect accuracy. C. The surfaces with the loosest tolerances to allow for later adjustment. D. The 2 largest opposing flat surfaces to establish parallel reference planes. The correct answer is D. The 2 largest opposing flat surfaces are machined first to establish parallel reference planes. These datum surfaces are then used to reference all subsequent operations, ensuring squareness and parallelism between all 6 faces. This sequence-dependent approach is fundamental to precision machining. Question 72. When clamping a workpiece directly to a milling machine table using strap clamps, where should the support block be positioned relative to the clamping bolt? A. Directly under the bolt head for maximum clamping force on the support. B. The support block height should match the workpiece height so the clamp is level and force is distributed evenly. C. The support block should be slightly higher than the workpiece so the clamp tilts toward the part. D. The support block should be much lower than the workpiece to create a lever advantage. The correct answer is B. The support block must match the workpiece height so the strap clamp sits level. A level clamp distributes the clamping force evenly between the workpiece and the support. If the support is lower, most of the force goes to the support; if higher, the clamp rocks and may slip. Question 73. Which tool holding device is used to mount a shell mill on a horizontal milling machine arbor? A. An end mill holder with a set screw locking the shank. B. A drill chuck with self-centering jaws. C. A side lock holder that grips the cutter by a flat on the shank. D. A shell mill arbor with a key drive and retaining bolt. The correct answer is D. A shell mill is mounted on a shell mill arbor that has a key drive to transmit torque and a retaining bolt to hold the cutter securely. The arbor fits into the spindle taper and provides rigid support for the large diameter face milling cutter. Question 74. What is the function of an arbor support on a horizontal milling machine? A. To hold the workpiece steady during heavy cutting operations. B. To support the outboard end of the arbor and prevent deflection during milling. C. To align the vise jaws parallel to the table travel direction. D. To store extra arbor spacers and collars during setup changes. The correct answer is B. An arbor support, overarm support, is positioned at the outboard end of the horizontal milling arbor to prevent deflection from cutting forces. Without this support, the arbor would flex during cutting, causing chatter, poor surface finish, and reduced cutter life. Question 75. What is the purpose of a dividing head on a milling machine? A. To divide the cutting fluid flow between multiple nozzles for even coverage. B. To divide the feed rate evenly between the X and Y axes for diagonal milling. C. To index the workpiece through precise angular divisions for gear cutting, spline milling, and fluting. D. To split the cutting depth equally between roughing and finishing passes. The correct answer is C. A dividing head, indexing head, rotates the workpiece through precise angular divisions. It is essential for cutting gears, splines, flutes on drills and reamers, and any feature requiring equally spaced angular positioning. Standard indexing uses a 40:1 worm gear ratio. Question 76. To mill 24 equally spaced teeth on a spur gear using a dividing head with a 40:1 worm ratio, how many full turns of the crank handle are needed between each tooth? A. 24 full turns of the crank handle per division. B. 40 full turns divided by 24, using a differential indexing plate. C. 2 full turns of the crank handle per division. D. 1 full turn plus 16 holes on a 24-hole circle. The correct answer is D. With a 40:1 dividing head, the indexing calculation is 40 divided by 24 is equal to 1 16 over 24 turns. This equals 1 full turn plus 16 holes on a 24-hole circle on the index plate. The sector arms on the plate are set to span 16 holes to ensure accurate and repeatable indexing. Question 77. When aligning a dividing head on a milling machine table, what inspection instrument verifies that the dividing head spindle axis is parallel to the table travel? A. A steel rule held against the dividing head body and the table edge. B. A dial indicator mounted on the machine spindle, sweeping a test bar held in the dividing head. C. A combination square placed on the table surface next to the dividing head. D. A thread pitch gauge used to check the alignment of the worm gear. The correct answer is B. A dial indicator mounted on the machine spindle is swept along a precision test bar held in the dividing head. Any deviation in the indicator reading as the table moves shows misalignment between the dividing head axis and the table travel, which must be corrected before milling. Question 78. When setting up a workpiece in a milling vise, what tool is used to locate the edge of the workpiece relative to the spindle center? A. A depth micrometer lowered from the spindle nose to the workpiece. B. A center punch applied to the top surface of the workpiece. C. An edge finder that deflects when it contacts the workpiece edge. D. A protractor placed against the vise jaw and the workpiece face. The correct answer is C. An edge finder is a spring-loaded tool held in the spindle that deflects visibly when it contacts the workpiece edge. The spindle position at the point of deflection, adjusted by the edge finder radius, establishes the exact edge location for setting work coordinates. Question 79. What is the difference between conventional, up, milling and climb, down, milling in terms of chip formation? A. Conventional milling produces thicker chips at entry that taper thinner, climb milling produces thin chips at entry that get thicker. B. Conventional milling produces no chips because the cutter rubs, climb milling shears material cleanly. C. Both methods produce identical chip thickness since the cutter geometry is the same. D. Conventional milling starts with a thin chip that gets thicker, climb milling starts with a thick chip that tapers thinner. The correct answer is D. In conventional milling, the cutter tooth engages the workpiece at 0 chip thickness and increases to maximum, which can cause rubbing at entry. In climb milling, the tooth enters at maximum chip thickness and decreases, producing a better surface finish and reduced tool wear but requiring a rigid setup and backlash elimination. Question 80. When selecting speeds and feeds for milling aluminium with a high-speed steel end mill, how do the recommended values compare to those for mild steel? A. Aluminium permits significantly higher surface speeds and feed rates due to its lower hardness and better machinability. B. Aluminium and mild steel use identical cutting parameters for the same cutter diameter. C. Aluminium requires significantly lower speeds to prevent material from gumming on the cutter. D. Aluminium requires the same speed but a much lower feed rate to prevent workpiece distortion. The correct answer is A. Aluminium has a much lower hardness and better machinability than mild steel, so it permits significantly higher surface speeds, often 3 to 5 times higher, and proportionally higher feed rates. This results in faster material removal rates and shorter cycle times when machining aluminium. Question 81. After tightening a precision milling vise onto the machine table, how is the fixed jaw verified to be parallel to the table's cross-travel axis? A. By running a dial indicator along the fixed jaw face while traversing the table in the x-axis. B. By placing a level across the top of the vise jaws and checking for bubble center. C. By milling a test cut and measuring the resulting angle with a protractor. D. By visual alignment of the vise body with the table T-slot edges. The correct answer is A. A dial indicator is mounted in the spindle or on a magnetic base and swept along the fixed jaw face while the table is traversed in the x-axis. Any variation in the indicator reading reveals misalignment, which is corrected by tapping the vise body before final tightening of the mounting bolts. Question 82. A machinist must mill a precision slot in a part that is too large to fit in the milling vise. What is the most secure alternative work-holding method? A. Holding the part with one hand while operating the table feed lever with the other. B. Resting the part on parallels directly on the table without any clamping. C. Clamping the part directly to the table using strap clamps, T-bolts, and step blocks. D. Using double-sided tape between the part and the table surface for adhesion. The correct answer is C. Strap clamps, T-bolts, and step blocks provide secure, rigid clamping directly to the milling table for oversized workpieces. The clamps must be positioned to resist cutting forces without interfering with the cutter path, and multiple clamps distribute the clamping force evenly across the part. Question 83. When selecting an end mill for a slotting operation, what relationship must exist between the end mill diameter and the desired slot width? A. The end mill must be half the slot width to make 2 overlapping passes. B. The end mill must be twice the slot width to allow for a finishing pass on each side. C. The end mill diameter should match the desired slot width for single pass full width slotting. D. The end mill diameter has no relationship to the slot width in conventional milling. The correct answer is C. For a single pass slotting operation, the end mill diameter should match the desired slot width. The full diameter of the end mill cuts both sides of the slot simultaneously. If the end mill is smaller than the slot width, multiple overlapping passes are needed with the workpiece repositioned for each pass. Question 84. When face milling a flat surface on a vertical milling machine, what determines the number of passes required to cover the full width of the workpiece? A. The spindle speed selected for the operation and the material hardness. B. The diameter of the face mill cutter relative to the workpiece width, allowing for overlap between passes. C. The total depth of material to be removed from the surface. D. The length of the workpiece measured parallel to the direction of feed. The correct answer is B. The number of passes is determined by the cutter diameter relative to the workpiece width. Each pass should overlap the previous one by approximately 1/3 of the cutter diameter to ensure full coverage and a consistent surface finish across the entire width. Question 85. When milling a pocket on a vertical milling machine, what technique is used to plunge the end mill into the material to begin the internal cut? A. A center cutting end mill is plunged straight down into the material like a drill. B. Both ramping and pre-drilling are acceptable methods depending on end mill capability and pocket geometry. C. A separate drill is used to create a starting hole, then the end mill is inserted to begin profiling. D. The end mill is ramped into the material at an angle using simultaneous X and Z axis feed. The correct answer is B. Both methods are acceptable. A center cutting end mill can plunge directly or ramp at an angle into the material. Alternatively, a starting hole can be drilled first with a drill bit, and the end mill inserted to begin pocket profiling. The choice depends on the end mill capability, pocket size, and material. Question 86. Which type of milling cutter is specifically designed to produce a T-shaped slot in a milling machine table or fixture plate? A. A Woodruff key seat cutter with a semicircular profile. B. A standard side and face milling cutter on a horizontal arbor. C. A dovetail cutter with an angled cutting edge. D. A T-slot cutter that mills the undercut after an initial straight slot is cut. The correct answer is D. A T-slot cutter is a specially shaped cutter that mills the horizontal undercut portion of a T-slot. A straight slot must first be cut with an end mill or side mill to provide clearance, then the T-slot cutter is passed through to create the wider undercut channel. Question 87. When milling a keyway in a shaft held in a dividing head on a horizontal milling machine, how is the correct keyway depth established? A. The cutter is lowered until it sparks against the shaft surface. B. A depth micrometer is inserted into the keyway after each pass to check progress. C. The keyway depth is estimated visually by comparing to a sample key. D. The shaft surface is touched off with the cutter, the dial zeroed, then the table raised by the specified keyway depth. The correct answer is D. The cutter is brought into light contact with the shaft surface, touch off, the knee elevation dial is zeroed, then the table is raised by the exact keyway depth dimension. This method ensures precise depth control reference from the shaft surface rather than an arbitrary starting point. Question 88. When cutting a spur gear on a milling machine using a form-type gear cutter, what determines the correct cutter number to select? A. The material hardness and the spindle speed of the milling machine. B. The center distance between the mating gear pair and the gearbox. C. The face width of the gear and the bore diameter of the blank. D. The number of teeth on the gear to be cut and the diametral pitch. The correct answer is D. Form-type gear cutters are numbered based on the range of tooth numbers they accommodate for a given diametral pitch. The correct cutter number is selected from a chart based on the number of teeth on the gear being cut. Each cutter number covers a range of tooth counts and produces the correct involute profile. Question 89. After cutting all teeth on a spur gear using a milling machine and dividing head, what inspection method verifies that the gear will mesh correctly with its mating gear? A. Measuring the outside diameter of the gear with an outside micrometer. B. Checking the tooth thickness at the pitch circle using a gear tooth vernier caliper. C. Counting the number of teeth and comparing to the drawing specification. D. Weighing the finished gear to verify that the correct amount of material was removed. The correct answer is B. A gear tooth vernier caliper measures the tooth thickness at the pitch circle, chordal thickness, and the chordal addendum simultaneously. This measurement verifies that the teeth have the correct profile thickness to mesh properly with the mating gear at the design center distance. Question 90. When drilling a series of precisely located holes on a milling machine, what method establishes the position of each hole relative to a reference edge? A. Scribing lines on the workpiece and aligning each line by eye with the spindle axis. B. Moving the workpiece by hand until a center punch mark aligns with the drill point. C. Drilling all holes at once using a multi-spindle drill head attachment. D. Using the calibrated handwheel dials or a digital readout to position the table to programmed coordinates. The correct answer is D. The calibrated handwheel dials or digital readout (DRO) system precisely positions the table to the required X and Y coordinates for each hole. After establishing the reference edge with an edge finder, the machinist moves the table by the specified increments to locate each hole accurately. Question 91. When reaming a hole on a milling machine, why must the spindle speed be significantly lower than the drilling speed used for the same material? A. Reamers have more flutes than drills and generate more heat per revolution, requiring slower speeds to prevent oversize holes and poor finish. B. Higher speeds would cause the reamer to drill a new hole rather than follow the existing one. C. Lower speeds allow the operator to observe the chip color more accurately. D. Reamers are made from softer material than drills and cannot withstand high speeds. The correct answer is A. Reamers have multiple cutting flutes that each remove a thin chip simultaneously, generating significant heat. Excessive speed causes thermal expansion of the reamer, producing an oversize hole, and can cause galling that ruins the surface finish. Speeds are typically 1/2 to 2/3 of the corresponding drilling speed. Question 92. What type of tooling is used for precision boring on a milling machine to achieve tight diameter tolerances? A. A standard twist drill with a split point geometry. B. An adjustable reamer with expandable blades. C. A boring head with a micrometer adjustable single point cutting tool. D. A hole saw with a centering pilot drill. The correct answer is C. A boring head mounts in the milling machine spindle and holds a single point boring bar that can be adjusted radially with a micrometer dial. This allows the machinist to set the exact bore diameter in increments as small as 0.01 mm, producing holes to very tight tolerances. Question 93. When tapping a hole on a milling machine, why is a tapping head with a clutch mechanism preferred over a rigid tap holder? A. The clutch mechanism increases the tapping speed for faster production. B. The clutch mechanism is only used for hand tapping outside of machine tools. C. A rigid holder works better because it provides more tapping force. D. The clutch reverses the tap automatically at the bottom of the hole and limits torque to prevent tap breakage. The correct answer is D. A tapping head with a clutch mechanism automatically reverses the tap rotation when the spindle reverses at the bottom of the hole, and the clutch slips if the torque exceeds a preset limit. This prevents tap breakage from excessive force, especially in blind holes where the tap could bottom out. Question 94. While milling a profile on a vertical milling machine, the machinist notices chatter marks appearing on the workpiece surface. The cutter is sharp and the speeds are correct. What is the most effective corrective action? A. Reduce the radial depth of cut and increase the number of passes to decrease cutting forces. B. Increase the spindle speed until the chatter frequency changes to a harmonic. C. Remove the coolant to eliminate any hydraulic dampening effects. D. Switch to a larger diameter cutter with fewer flutes to increase chip load per tooth. The correct answer is A. Chatter during milling is often caused by excessive cutting forces that exceed the rigidity of the setup. Reducing the radial depth of cut decreases the forces acting on the cutter and workpiece, which is the most direct and effective way to eliminate chatter while maintaining acceptable speeds and feeds. Question 95. A machinist needs to face mill a large cast iron plate on a horizontal milling machine. The first pass produces an acceptable surface, but subsequent passes leave a visible step at the overlap. What is causing this? A. The cutter teeth are coated with built-up edge material from the cast iron. B. The feed rate was accidentally changed between the first and second passes. C. The cast iron plate is expanding from heat generated during the first pass. D. The spindle axis is not perpendicular to the table surface, causing the cutter to tilt and cut deeper on one side. The correct answer is D. A visible step between overlapping face milling passes indicates that the spindle axis is not perpendicular to the table surface. The tilted cutter produces a slightly concave surface on each pass. When passes overlap, the concave profiles create a step at the junction. The spindle head must be trammed to correct this. Question 96. What is the correct procedure for cutting a dovetail slot on a milling machine? A. Use a dovetail cutter in a single pass to produce the complete profile. B. Use a fly cutter set to the dovetail angle to produce both angled surfaces simultaneously. C. First cut a rectangular slot with an end mill, then use a dovetail cutter to produce the angled sides. D. Tilt the milling head to the dovetail angle and use a standard end mill for each side. The correct answer is C. A dovetail slot is cut in two stages. First, a rectangular slot is milled with a standard end mill to provide clearance for the dovetail cutter, then the dovetail cutter is used to produce the angled undercut sides. The dovetail cutter cannot plunge into solid material. Question 97. Which type of precision grinding machine is used to grind the outside diameter of a cylindrical workpiece held between centers? A. A surface grinder with a horizontal spindle and reciprocating table. B. A tool and cutter grinder with a universal head and work-holding collet. C. A centerless grinder with a regulating wheel and work rest blade. D. A cylindrical grinder with the workpiece rotating between headstock and tailstock centers. The correct answer is D. A cylindrical grinder holds the workpiece between centers, headstock and tailstock, while it rotates against the grinding wheel. The wheel traverses along the workpiece length to grind the outside diameter to precise dimensions and a fine surface finish. Question 98. What grinding wheel abrasive is recommended for grinding hardened tool steel and high-speed steel tools? A. Silicon carbide, which is best for hard, brittle ferrous materials. B. Diamond, which is used exclusively for all steel grinding applications. C. Aluminum oxide, which is the standard abrasive for ferrous metals including hardened steel. D. Cubic boron nitride, CBN, which is softer than aluminum oxide but cuts faster. The correct answer is C. Aluminum oxide is the standard abrasive for grinding ferrous metals, including hardened tool steel and high-speed steel. It is tough, sharp, and self-sharpening as it fractures during grinding. CBN is used for very hard steels in production, and silicon carbide is for non-ferrous materials. Question 99. When setting up a workpiece on a surface grinder magnetic chuck, what must the machinist verify before starting the grinding operation? A. That the grinding wheel is rotating in the opposite direction to the table travel. B. That the coolant has been turned off to prevent the magnetic field from weakening. C. That the workpiece extends at least 25 mm beyond the edge of the magnetic chuck. D. That the workpiece is ferrous and makes full flat contact with the chuck surface for secure holding. The correct answer is D. The workpiece must be ferrous, magnetic, and have a flat, clean bottom surface that makes full contact with the magnetic chuck. Poor contact results in weak holding force, and non-ferrous materials will not be held at all. The machinist should also verify the holding force by trying to slide the workpiece before grinding. Question 100. Before mounting a new grinding wheel on a precision grinder, what safety inspection must be performed? A. The wheel must be weighed to verify it does not exceed the maximum spindle load rating. B. The wheel must be pre-balanced by spinning it on a test mandrel at full operating speed. C. The wheel must be soaked in cutting oil for 24 hours to prevent thermal shock. D. The wheel must be ring-tested by suspending it and tapping lightly to detect cracks. The correct answer is D. A ring test is performed by suspending the wheel on a pin or finger and tapping it lightly with a non-metallic object. A clear ring indicates a sound wheel, a dull thud indicates a crack. Cracked wheels can explode at operating speed, causing serious injury. This inspection is required before every wheel mounting. If you're finding these questions helpful, please subscribe and hit the bell icon. It helps other apprentices find this resource too. Now let's continue. Question 101. What is the purpose of dressing a grinding wheel during a precision grinding operation? A. To apply a protective coating that extends the wheel life between replacements. B. To reduce the wheel diameter so it fits within the wheel guard clearance. C. To restore the cutting ability by exposing fresh sharp abrasive grains and truing the wheel face. D. To lubricate the wheel surface to prevent the workpiece from overheating. The correct answer is C. Dressing exposes fresh, sharp abrasive grains by removing dulled and loaded, clogged, grains from the wheel surface. It also trues the wheel face to restore the correct profile. A diamond dressing tool is typically used, and regular dressing maintains consistent cutting performance and surface finish quality. Question 102. In the grinding wheel marking system, what does the grade letter, such as J, K, or L, indicate about the wheel? A. The type of abrasive grain used in the wheel, aluminum oxide, silicon carbide, etc. B. The hardness of the bond that holds the abrasive grains, determining how easily grains release. C. The grit size or coarseness of the abrasive particles in the wheel. D. The maximum operating speed in meters per second for the wheel. The correct answer is B. The grade letter indicates the bond hardness, how strongly the bond holds the abrasive grains. Soft grade wheels, AH, release grains easily, staying sharp but wearing fast. Hard grade wheels, OZ, hold grains longer, lasting longer but potentially glazing. Selection depends on the workpiece material and operation. Question 103. When grinding a flat surface on a surface grinder, how is the initial contact between the grinding wheel and workpiece established? A. The wheel is plunged rapidly into the workpiece to remove the oxide layer. B. The wheel is brought to a stop, lowered onto the workpiece, then restarted at full speed. C. The wheel is lowered slowly onto the workpiece while the table reciprocates, until sparks indicate contact. D. A feeler gauge is placed between the wheel and workpiece to set the initial gap. The correct answer is C. The wheel is lowered in very small increments, typically 0.01 to 0.02 millimeters, while the table reciprocates and coolant flows. The appearance of sparks across the full workpiece width indicates uniform contact has been established. This becomes the zero reference for subsequent depth of cut settings. Question 104. When grinding a profile or form on a surface grinder, how is the grinding wheel prepared to produce the required shape? A. A standard flat grinding wheel is used at an angle to approximate the profile shape. B. The wheel is dressed to the required profile using a diamond dresser guided by a template or radius attachment. C. The workpiece is moved in a programmed path while the flat will remain stationary. D. Multiple wheels of different shapes are stacked on the spindle to produce the combined profile. The correct answer is B. The grinding wheel is dressed to the required profile shape using a diamond dressing tool guided by a template, radius dressing attachment, or CNC dresser. The profiled wheel then transfers its shape to the workpiece surface during grinding, producing the desired form accurately. Question 105. When grinding the outside diameter of a shaft on a cylindrical grinder, what indicates that the grinding wheel needs to be dressed? A. The surface finish deteriorates, burn marks appear, and the wheel appears shiny or glazed. B. The workpiece diameter is increasing despite additional grinding passes. C. The coolant changes color from green to brown during the operation. D. The headstock motor draws less current than normal during grinding. The correct answer is A. A glazed or loaded grinding wheel has dulled abrasive grains and clogged pores that rub instead of cutting. This produces a deteriorated surface finish, burn marks on the workpiece, indicating excessive heat, and increased grinding forces. Dressing the wheel exposes fresh sharp grains to restore cutting performance. Question 106. When sharpening the cutting edge of a high-speed steel end mill on a tool and cutter grinder, what must be maintained to preserve the tool's cutting geometry? A. The original primary and secondary clearance angles and the radial rake angle of each flute. B. The original flute helix angle only, as the other angles are not critical. C. Only the overall length of the end mill needs to match the manufacturer's specification. D. The color of the cutting edge must remain silver, indicating no heat damage occurred. The correct answer is A. The primary clearance, secondary clearance, and radial rake angles must be maintained to preserve the cutting geometry that gives the end mill its performance characteristics. Incorrect angles cause rubbing, excessive cutting forces, poor chip evacuation, and premature tool failure. Question 107. A precision bore must be finished to an extremely tight tolerance and a surface finish of RA 0.2 micrometers after cylindrical grinding. What finishing operation achieves this specification? A. A second grinding pass with a finer grit wheel and reduced feed rate. B. Lapping the bore with a loose abrasive paste and a rotating lap tool. C. Honing with an expanding abrasive stone that reciprocates within the bore. D. Polishing the bore with a felt wheel and buffing compound. The correct answer is C. Honing uses expanding abrasive stones that reciprocate within the bore, producing a cross-hatched pattern with an extremely fine surface finish. Honing removes very small amounts of material, 0.01 to 0.05 millimeters, and can achieve surface finishes of RA 0.1 to 0.4 micrometers while correcting minor form errors from grinding. Question 108. What information is typically included in a CNC process documentation sheet, setup sheet, for a machining operation? A. Work holding method, tool list with offsets, work datum location, and operation sequence. B. Only the G-code program listing and the operator's name. C. The purchase order number and the customer's billing address. D. Only the raw material specification and the final part weight. The correct answer is A. A CNC process documentation sheet includes the work holding method, complete tool list with tool numbers and offset values, work datum, origin, location, operation sequence, speeds and feeds, and any special instructions. This document ensures consistent setup by any operator and supports quality control. Question 109. In CNC programming, what does the G-code G01 command instruct the machine to do? A. Circular interpolation in a clockwise arc to a specified endpoint. B. Rapid traverse to a specified position at maximum machine speed. C. Linear interpolation, move to a specified position at a programmed feed rate in a straight line. D. Return to the machine home position and reset all axis counters. The correct answer is C. G01 commands a linear interpolation move, which moves the cutting tool in a straight line from the current position to the specified endpoint at a programmed feed rate. It is the fundamental cutting motion command used for turning, milling, and other material removal operations. Question 110. What is the difference between absolute, G90, and incremental, G91, coordinate programming in CNC? A. G90 uses inch units while G91 uses metric units for all axis positions. B. G90 programs spindle speed, G91 programs feed rate values. C. G90 is for milling operations only, G91 is for turning operations only. D. G90 references all positions from the work datum origin, G91 references each move from the current tool position. The correct answer is D. In absolute mode, G90, all coordinate positions are referenced from the work datum origin point, x0, y0, z0. In incremental mode, G91, each coordinate is the distance and direction from the current tool position to the next position. Most programs use absolute coordinates for clarity and error prevention. Question 111. In CNC programming, what does the M-code M05 command? A. Turns on the coolant flood for the machining operation. B. Stops the spindle rotation. C. Ends the CNC program and resets to the beginning. D. Activates the automatic tool changer to index to the next tool. The correct answer is B. M05 is the standard M-code that stops the spindle rotation. It is typically used before tool changes, workpiece measurement, and at the end of machining operations. The corresponding spindle start codes are M03, clockwise, and M04, counterclockwise. Question 112. When writing a CNC program to machine a circular pocket, which G-codes are used to program the circular arc segments? A. G02 for clockwise circular interpolation and G03 for counterclockwise circular interpolation. B. G00 for clockwise arcs and G01 for counterclockwise arcs. C. G90 for full circle arcs and G91 for partial arc segments. D. G28 for clockwise arcs returning to home and G30 for counterclockwise arcs. The correct answer is A. G02 commands clockwise circular interpolation and G03 commands counterclockwise circular interpolation. Both require the endpoint coordinates and either the arc center, I, J, K values, or the arc radius, R value, to define the circular path the tool follows. Question 113. When transferring a CNC program from a computer to the machine control, what edit function allows the programmer to modify specific values without rewriting the entire program? A. The search and replace function that finds and alters specific codes throughout the program. B. The delete function that removes the entire program from memory for a fresh transfer. C. The export function that sends the program to an external printer only. D. The copy function that duplicates the program into a backup file location. The correct answer is A. The search and replace, alter, edit function allows the programmer to find specific codes, values, or text strings in the program and replace them with new values. This is one of the standard edit functions: insert, alter, delete, copy, paste, export, used for program management in CNC controls. Question 114. After a CNC program has been proven and is cutting parts, how does the machinist optimize the program to reduce cycle time? A. By removing all safety blocks and rapid positioning moves from the program. B. By adjusting feed rates, speeds, and rapid positioning heights based on observed cutting conditions and reducing air cutting time. C. By switching from absolute to incremental coordinates throughout the program. D. By removing all tool change commands and using a single tool for all operations. The correct answer is B. Program optimization involves adjusting feed rates and speeds based on actual cutting performance, increasing where possible, reducing where needed, minimizing rapid approach distances, reducing dwell times, and eliminating unnecessary air cutting moves, all while maintaining part quality and tool life. Question 115. What coordinate system is used as the foundation for CNC programming to define tool positions in three-dimensional space? A. The Cartesian coordinate system using X, Y, and Z axes. B. The polar coordinate system using radius and angle values. C. The cylindrical coordinate system using radius, angle, and height. D. The spherical coordinate system using radius and two angle values. The correct answer is A. CNC programming is based on the Cartesian coordinate system with three mutually perpendicular axes, X, Y, Z. For milling machines, X and Y define the horizontal plane and Z is vertical. For lathes, X defines the diameter direction and Z is the longitudinal axis. Question 116. What is the primary function of a postprocessor in CAM, computer-aided manufacturing, software? A. To convert the CAM toolpath data into machine-specific G-code that the CNC control can execute. B. To create the 3D solid model of the part from engineering drawings. C. To simulate the cutting operation visually on screen before generating any code. D. To calculate the material cost and machining time for the production estimate. The correct answer is A. A postprocessor translates the generic toolpath data generated by the CAM software into the specific G-code format required by a particular CNC machine and control. Different machines use different code formats, so a unique postprocessor is needed for each machine control combination. Question 117. When programming a contour in CAM software, what must be defined to ensure the tool compensates for its radius when following the part profile? A. The maximum spindle speed and the minimum coolant flow rate. B. The tool knows radius compensation direction, left or right of the programmed path. C. The tool material grade number and coating type. D. The workpiece weight and the clamping force required. The correct answer is B. Tool knows radius compensation, cutter radius compensation, must be defined so the CNC control offsets the tool path by the tool's radius to the left, G41, or right, G42, of the programmed contour. Without this compensation, the tool center would follow the part profile, cutting the part undersize or oversize. Question 118. When programming a CNC lathe to cut a thread, which G-code is typically used for a single-pass threading cycle? A. G01 with a Z-axis feed matching the thread pitch. B. G00 with the feed override set to match the thread pitch value. C. G02 for a clockwise helical interpolation along the thread path. D. G32 or G33 for constant lead threading synchronized with spindle rotation. The correct answer is D. G32, or G33 on some controls, is the basic threading G-code that synchronizes the Z-axis feed with spindle rotation to produce a constant lead thread. The feed per revolution equals the thread pitch, and the control uses a spindle encoder to maintain synchronization between rotation and axis movement. Question 119. When creating a 3D model in CAD for CNC machining, what feature must be included to ensure the CAM software generates toolpaths that avoid collisions with the work holding? A 3D model of the fixture and clamps included in the CAM setup alongside the part model. B. A detailed material specification table embedded in the model file. C. A written note attached to the model describing the clamp positions. D. A separate drawing of the fixture stored in a different folder on the network. The correct answer is A. Including a 3D model of the fixture, clamps, and work holding in the CAM setup allows the software to check for collisions between the tool, holder, and work holding during toolpath generation. This prevents crashes during machining that would damage the part, tooling, and machine. Question 120. A CNC milling program runs correctly in simulation, but the first part has a dimensional error of exactly 1 mm on all x-axis features. All y and z dimensions are correct. What is the most likely cause? A. The spindle speed is set 1 mm over min too fast for the material being cut. B. The work datum x-axis origin was set 1 mm off from the correct position during setup. C. The CAM post-processor converted all x dimensions from inches to millimeters incorrectly. D. The machine's x-axis ball screw has 1 mm of wear along its entire length. The correct answer is B. A consistent dimensional error on a single axis with all other axes correct indicates the work datum origin for that axis was set incorrectly. If the x origin was picked up 1 mm off from the true reference edge, every x-axis dimension in the program would be shifted by that exact amount. Question 121. What is the primary advantage of using qualified tooling, preset tool holders, in a CNC machining center? A. Qualified tooling has known, repeatable dimensions that reduce setup time by eliminating on-machine tool measurement. B. Qualified tooling eliminates the need for any tool length offsets in the program. C. Qualified tooling can only be used on one specific brand of CNC machine. D. Qualified tooling is less expensive than standard tool holders for all applications. The correct answer is A. Qualified, preset, tooling has known, repeatable gauge dimensions established on an offline tool presetter. The tool length and diameter offsets can be loaded directly into the CNC control without time-consuming on-machine touch-off procedures, significantly reducing setup time between jobs. Question 122. When installing tools in a CNC machining center's tool magazine, what determines the location of each tool in the magazine? A. Each tool must be loaded in the magazine pocket that matches the tool number called in the program. B. Tools are always loaded in order from smallest to largest diameter. C. Tools are loaded randomly and the machine automatically identifies each one. D. The heaviest tools must always be in the lowest magazine pocket positions. The correct answer is A. Each tool must be loaded in the magazine pocket corresponding to the tool number called in the CNC program. When the program calls for a tool change, e.g., T05M06, the tool changer retrieves the tool from pocket 5. Loading a tool in the wrong pocket causes the machine to use the wrong tool, potentially crashing or scrapping the part. Question 123. What method is used to determine tool length offsets when setting up tooling on a CNC milling machine? A. Estimating the length visually and entering an approximate value. B. Measuring the tool holder length only, ignoring the cutting tool projection. C. Using the same offset value for all tools regardless of their actual length. D. Touching off each tool on the workpiece surface or using a tool length presetter, then entering the measured value into the offset register. The correct answer is D. Tool length offsets are determined by touching each tool on a reference surface, workpiece top or gauge block, or by using a tool length presetter. The measured distance from the spindle gauge line to the tool tip is entered in the corresponding offset register, allowing the control to compensate for each tool's unique length. Question 124. When establishing the work datum, work coordinate origin, on a CNC milling machine, what tool is commonly used to locate the workpiece edges? A. A standard twist drill touched against the workpiece surface by eye. B. A center punch used to mark the origin point on the workpiece surface. C. An electronic edge finder or touch probe that signals when it contacts the workpiece. D. A tape measure stretched from the machine home position to the workpiece corner. The correct answer is C. An electronic edge finder or touch probe is used to precisely locate the workpiece edges. The edge finder deflects or triggers a signal at the exact point of contact, and the machine position at that point, adjusted by the finder radius, is recorded as the work coordinate origin in the offset table. Question 125. What is the safest method to verify a new CNC program before running it at full speed on a workpiece? A. Running the program at full speed on the first part and measuring after completion. B. Reading through the printed G-code listing and checking for errors visually. C. Dry running the program with the tool raised above the workpiece using single block mode and reduced feed override. D. Running the program once with the spindle off to see if the axes move correctly. The correct answer is C. A dry run with the tool raised safely above the workpiece in single block mode, executing one line at a time, with reduced feed override allows the machinist to verify each movement before committing to a full-speed cut. This identifies programming errors, unexpected rapid moves, and collision paths before any contact with the workpiece. Question 126. What is the difference between the machine home position and the work datum in CNC machining? A. They are the same point, both refer to the origin of the coordinate system. B. Machine home is a fixed reference point on the machine, work datum is the programmable origin on the workpiece. C. Machine home is where the operator stands, work datum is where the part is clamped. D. Machine home is used only for turning, work datum is used only for milling. The correct answer is B. The machine home position is a fixed reference point established by limit switches or encoders on the machine structure. The work datum, work coordinate origin, is a programmable origin point set by the machinist on the workpiece surface. The offset between these 2 points is stored in the work offset register. Question 127. When selecting CNC tooling, why must the tool holder be checked for cleanliness and damage on the taper surface before installation? A. Dirt on the taper surface changes the tool offset value stored in the register. B. A dirty taper surface prevents the coolant from flowing through the tool. C. Contamination or damage on the taper prevents proper seating, causing runout and potential tool pull-out. D. Damage on the taper voids the tool holder manufacturer's warranty only. The correct answer is C. The taper surface is the precision interface between the tool holder and the machine spindle. Any contamination, chips, coolant residue, or damage, nicks, burrs, prevents the taper from seating fully, causing tool runout, vibration, poor surface finish, and in severe cases, the tool pulling out of the spindle during cutting. Question 128. During program verification on a CNC lathe, the tool moves to the correct X position but plunges past the programmed Z endpoint on a turning pass. The program code appears correct. What should the machinist investigate first? A. Whether the spindle speed is causing the tool to vibrate past the Z limit. B. Whether the tool length offset in the Z-axis register contains an incorrect value. C. Whether the workpiece material is softer than expected, allowing deeper penetration. D. Whether the X-axis offset is causing a compound error in the Z direction. The correct answer is B. If the Z-axis moves past the programmed endpoint while X is correct, the most likely cause is an incorrect Z-axis tool length offset. The offset value shifts all Z positions by the error amount. This should be verified by comparing the measured tool length to the value in the offset register. Question 129. After measuring the first part produced by a CNC program, the outside diameter is 0.05 mm oversize. How should the machinist correct this? A. Edit the program to change all X-axis coordinates by 0.05 mm. B. Increase the spindle speed to remove the extra 0.05 mm of material on the next part. C. Adjust the tool wear offset for the turning tool by the measured deviation to bring the diameter into tolerance. D. Replace the cutting insert with a new one that has a sharper edge. The correct answer is C. The tool wear offset is adjusted by entering the measured deviation. For an oversized diameter, a negative wear offset value causes the tool to cut closer to the axis, removing the additional material. This method preserves the original program dimensions and allows fine adjustments without code changes. Question 130. On a CNC lathe, what is the relationship between the programmed X-axis value and the workpiece diameter? A. The X value always equals the workpiece radius, half the diameter. B. The X value equals twice the workpiece diameter to account for both sides. C. The X value has no direct relationship to the workpiece diameter. D. The X value equals the workpiece diameter when programmed in diameter mode, which is standard for most CNC lathes. The correct answer is D. Most CNC lathes are programmed in diameter mode, where the X-axis value directly represents the workpiece diameter. When the program commands X 25.0, the tool moves to produce a 25.0 mm diameter. Some machines can be switched to radius mode, but diameter mode is the industry standard. Question 131. While monitoring a CNC machining process, the operator notices unusual vibration and a change in cutting sound during a roughing operation. What should be done? A. Ignore the changes as they are normal variations during roughing operations. B. Use the feed hold button to pause the operation, then investigate the cause before continuing. C. Increase the feed rate override to push through the difficult section faster. D. Press the emergency stop immediately without assessing the severity of the situation. The correct answer is B. Feed hold pauses the machining operation safely, maintaining spindle rotation and coolant flow while stopping axis movement. This allows the machinist to investigate the cause, which could be tool wear, chip buildup, loose workpiece, or material inconsistency, without the abrupt stop of an emergency stop that could damage the part or tooling. Question 132. During a CNC milling production run, the operator observes that the coolant flow has decreased significantly. What condition should be checked? A. Whether the spindle speed has automatically increased above the programmed value. B. Whether the work offset values have shifted due to thermal drift of the machine. C. Whether the coolant concentration, level, and nozzle direction are correct and the filter is not clogged. D. Whether the tool magazine has rotated to an incorrect pocket position. The correct answer is C. Reduced coolant flow is typically caused by a low coolant level in the sump, a clogged filter or nozzle, incorrect nozzle direction, or a failing coolant pump. The machinist should verify coolant level and concentration, clean or replace the filter, and redirect the nozzle to ensure adequate flow to the cutting zone. Question 133. What is the purpose of the feed-hold function on a CNC machine control? A. To permanently stop the program and reset all axes to the home position. B. To switch the machine from automatic mode to manual jog mode permanently. C. To reduce the feed rate to exactly 50% of the programmed value. D. To pause axis motion while maintaining spindle rotation and coolant, allowing the cycle to be resumed. The correct answer is D. Feed-hold pauses all axis motion while the spindle continues to rotate and coolant continues to flow. The program is suspended at the current line and can be resumed by pressing the cycle start button. This allows the operator to inspect the part, check measurements, or verify cutting conditions without losing the program position. Question 134. After a power interruption during a CNC machining cycle, what procedure must be followed before restarting the program? A. Simply press cycle start to resume from where the program stopped. B. Remove the workpiece and start a new part from the beginning of the program. C. Rehome the machine axes, verify the tool and work offsets, then use the program restart function to resume from the correct line. D. Turn off the machine for 30 minutes to allow the control memory to reset. The correct answer is C. After a power interruption, the machine loses its position reference. The axes must be rehomed to re-establish the coordinate system, then tool and work offsets must be verified to ensure they were not corrupted. The program can then be restarted from the appropriate line using the control's restart or search function. Question 135. During a CNC production run, parts are gradually trending oversize in diameter over the last 20 parts. Each part is slightly larger than the previous one. What is the most likely cause of this progressive dimensional drift? A. Progressive tool wear is reducing the effective cutting diameter, requiring a wear offset adjustment. B. The CNC program has a cumulative rounding error that compounds with each cycle. C. The coolant concentration is changing the thermal expansion coefficient of the workpiece. D. The work datum shifts exactly 0.001 mm after each completed cycle due to a software bug. The correct answer is A. Progressive dimensional drift over multiple parts is the classic symptom of gradual tool wear. As the cutting edge wears, it removes slightly less material with each part, causing diameters to trend oversize. The machinist must adjust the tool wear offset to compensate, or replace the insert when wear exceeds the offset correction range. That's all the questions for today. If this helped you prepare, subscribe now and hit the bell. We post exam prep for all Red Seal trades. Visit questionbankhub.com for the complete study guide with additional practice questions. Good luck on your Machinist Red Seal exam. You've got this.